Community wrestle.
Welcome to Miss Benzi's QL Spring 2019 Week 4 Group Project by John Tenney, McCree Martin, Christian, Janet Bailey, and Lydia. And Lydia is going to start by asking the first question.
My apologies.
Cue card.
I can't see her cue cards. I was trying to do it this way. What is the speed? There's no chance.
Question one.
All right, so what is the speed that we're moving, even if we're sitting still, Christian?
Well, speed is relative because speed is measured by a fixed point. So, for example, if I was near the equator, would I be moving 0 miles per hour or 1,000 miles per hour? I would actually be moving 1,000 miles per hour because of the Earth's rotation. So speed is completely relative because it's measured by comparing it to a fixed point.
Thanks, Christian.
And the second question for Christian, Lydia.
We're going to help Lydia out. She's having a time seeing it.
Yes, go ahead and pick up the ball wherever you guys can.
Question two for Christian would be, what is your favorite aspect of the scale of the universe?
This is my easy question out of my 6, but my favorite aspect of the scale of the universe was the Japanese spider crab. It's the largest crustacean on Earth, and it's a crab that is larger than a human.
Yikes. Sounds scary to me.
Great.
So, next question, next slide. Okay, this is a question for Lydia. Did you shrink Hoover Dam?
I love contrast, but no, I didn't shrink Hoover Dam. Actually, Angel Falls added up to more than all the man-made things in the center of the picture. And but there's always something bigger. Uluru, as the Aboriginal name for Ayers Rock, is actually 3 times as long as, and Angel Falls is taller. And if you put them all in the Mariana Trench, they wouldn't reach the top.
Wow, that was interesting. Thanks, Lydia.
Question 3 for Martin, or McCree Martin. We're asking, we're calling him M&M Blues, what we're calling him. So who would you use the x-axis and y-axis to fool you on the difference in numbers, like in the Bill Clinton campaign?
Well, the difference in numbers that they used in the Bill Clinton campaign was actually that the x and y axis, the x-axis on the left side is not 0. So when you're looking at the bar graph, it is, I guess, in smaller increments than the rest. So you can see that in the original top one, the original top bar graph, that Clinton looks like he's winning by a huge amount. But in reality, in the bottom left bar graph, Clinton is just winning by a slight little hair compared to Bush. And then you can also see it in the Boulder scores I have right over here to the right, with the actual scores from 100 and the scores from 100 and the actual scores from 0.
Thanks, McCree.
Question number 6.
Question number 4.
5. Yeah, 4. Sorry.
It goes to Lydia. What is the difference in the 3 bar graphs?
Well, as you can see, the first one that we have is just a comparison of the range between the distance between Hildy's score and Emily's. But if you do it honestly so that you can tell what you're looking at, the 6 points between Hildy's score and Emily's really isn't that much if you add the other 100.
Great, thanks, Lydia.
Question 5.
So, Tinny, how can bar charts skew information?
Bar charts can skew information, just as we were talking earlier about the Bill Clinton campaign. The one bar chart didn't start at 0. It started like at 5.17%, and went to 5.21%. So they kind of just like in a good book, you can prove anything with with the scripture if you want to. Well, the same thing with the bar graph, you can do the same thing with it. But if you start at a real true standard, the actual percentage rate between the two, as Martin said a few minutes ago, was only 0.02%. So the bar graph, depending on how it's written or depending on where you start with it, that's how you can skew the information.
Wow, that's super interesting. Thanks for sharing that, Tinny.
I asked next one. I don't have, what am I supposed to be
And the
doing?
question is right at the bottom of the screen.
Explain how bar graphs, Janet Bailey, can be misleading in real life.
Well, as you said, they can use different numbers to make them look like they sway one way or another. For instance, if you look down here at the clothing company, it looks like the center one is much bigger than the rest of them. But if you really take a look at it, it's actually smaller than the rest of the circles. No, it's, yeah. McCree, how can graphs be misleading in the arena graph pie chart?
It's just as you said, actually. They're using different colors and not showing the actual true how much amount that they used. So on the arena funding to the left, you can see that they're showing around halfway percent. But on the right is way over more halfway percent. It's probably actually around 70. Well, it says right there, 65%. And I guess they're hiding it from the public to show that their contributors put in just as much money as they did.
Well, we sure need to watch out for misleading graphs, don't we, guys?
We do.
Thanks, McCree.
8.
Number 8.
Yeah. John, this one goes to Tinny. What is the mean and how is it determined? And how does the mean affect trend lines?
The mean, if you look at these graphs here, they're talking about heights of Army recruits in inches and heights of random mall shoppers in inches. If you look at the mean on the Army recruits graph, it shows the mean there to be 72.3333 inches. The mean is derived, it's kind of like the average of all the numbers that you enter into the data and then divide it by, you add all the numbers up and then divide it by how many numbers it is. And what the mean does with trend lines, if you look at the trend lines in the height of Army recruits in inches, it barely moves and all the little dots are just barely above and below it because most of the Army recruits are usually men and they're usually about the same height. Whereas random mall shoppers, we had one that was 34 inches tall and one all the way up to, looks like 77 inches tall. And so we're all over the place. And the trend line on it, you can see some dots and inches are way above the trend line and some of them are way below the trend line. And that's how that affects those, because the mean is so much different. The mean on the random mall shoppers was 58 inches, which is way in the middle of that wide span of numbers that we had there.
Very good.
And then number 9, I'm supposed to ask Miss Bailey, explain the difference. The difference in standard deviation is different with the Army recruits versus the random mall walkers. Explain how the difference is.
Well, the mall, let's see here. The mall and the mall walkers and the Army recruits, the standard deviation is so much different because the subjects are so much different. So the Army recruiters have around the same level of subject matter compared to the random mall walkers. If you look at the graph, the random mall walkers, the shortest person was 34 inches, but on the Army recruits, the shortest person is 71 inches. So the subjects for the Army recruiters compared to the random mall walkers is different, which is why the standard deviation is so much greater on the mall walkers compared to the Army recruiters. And how is the median different from the mean?
The median is different from the mean. If you look at these same charts again, the mean we said is the average basically of all the numbers that we have, whereas the median is going to be, if you look at the bar and whisker chart down below, you can see a Q1, a median, and a Q3. The median on this was the number that was in between the ordered number. We have 4 numbers above it and 4 numbers below it, so the median is the number right in the middle. When you go to try to find the different quartiles, you have to basically do the same type of calculation you would for a mean and divide 70 or add 74 and 75 and then divide it, and you come up with a 74.5, I believe it says. And the same thing on a Q3 on the bottom, that is the median of those numbers. And you can tell by the way it is on the bar and whisker chart, you'll see that the Army recruit people are just a few inches of, above and below the main bar, which is kind of like the trend line. Whereas you go to the mall shoppers, you can see it's quite a bit different. On the first quartile, it's 70, which is the mean or the median. And then on the third quartile, it's 47. So it's quite a bit of difference there. And you can see the bar and whisker chart that the top one is a little ways above the main fat bar, whereas the bottom one is quite a bit different than the bar. And let's see, I'm asking the next one. Is that right? No, who's got 16?
11.
Yeah, 11 is to Janet. Why is the mall walker plot and whisker so much wider than the Army recruits?
Well, it kind of goes back to the last question that I answered. If you see on the height of the Army recruit in inches, it's a lot skinnier and more narrow, and that is because the test subjects are very similar. On the height of the random mall walkers, the graph is a little bit shorter and wider, and that is because there's such a large variation in the number of information given from the test subjects. And this one is for Christian. How can you see the slope through this section of the hours of sleep graph? Oops.
Oh, okay. So you can see the slope through these graphs. As you can see that we made rectangles to show all the sections of this graph. And this is a trend line over time that shows sleep patterns. The reason we're able to see the slope through the graph is we made transparent shapes. Transparent shapes are a good aspect for Microsoft Excel with making graphs because transparent shapes allow you to see percentages and the slopes of the graphs through sections. So you can sectionize, off your graphs, but still be able to see them. So basically we made shapes and we used Excel to make the shapes transparent through the graphs.
And explain the green symbol that is represented on the flamethrower sales graph.
So the green symbol is our break-even point. You can see the graph slopes down with the yellow point. That's where we lose a little bit of money. That's our first initial investment. The green point, however, is the break-even. The break-even means any sales after that point will be pure profit. So the break-even point is basically an indicator on our graph to show that any sales moving forth will be profit to the company.
Okay.
Great, thanks, Christian.
I'm not sure what happened.
That's okay. Whose question is this? We can just ask it.
Yeah, mine got mixed up.
Okay.
13, that's where we're on, right? I
Should be.
asked Timmy, how do Venn diagrams help to analyze data?
We'll find it.
Go to
Keep going.
Go to slide 15.
There it is.
Venn diagrams help to analyze data in that they, on this chart here, you can see there's people that are obese, there's people that have type 2 diabetes, and there's people that have high blood pressure. And they intermingle amongst each other because most people that are obese have one or two of these other problems, or even three of these other problems, as it shows by 8.5% right in the very middle. And you'll see the different percentages that have of the American population that have these different health issues. And the way we got to those numbers is there's a little upside down U in this diagram just above it. The little upside down U, the little Greek symbol there means that and so-and-so. You know, it's like they have that group and another group and another group. And we had to start at the bottom with it and then work our way up. Once we were trying to figure this out, we were trying to figure the numbers out. And so we had all the people that were obese, had type 2 diabetes, and high blood pressure. That gave us a number of Americans that had that problem. And then we went up from there, you know, wanted to know who had just was obese and had high blood pressure, or who had type 2 diabetes and high blood pressure, and all the way up to the very top. We got everybody included in this.
Very good. Thank you, Tinny.
Let's see.
This one.
I'm on 17 already. All right, this is back to Christian. Is that right? Are we on 17?
Just run with it.
Okay.
Okay. Christian, you ready?
Mhm.
All right. How can graphs be misleading?
This was slightly answered earlier, but graphs can be misleading in a lot of ways. As you can see, the Clinton-Bush years were already compared. For my Excel, I actually had to start the base at 0. So that allowed us to see the truth of the graphs. We weren't able to automatically add that. So as you can see in our chart, we added 0% as a part of the base of the graph. Once we did that, that showed that the Clinton years and the Bush years unemployment rate was actually pretty similar. So graphs can be misleading depending on the base that they're compared to, and definitely the ranges of percentages can show a difference aesthetically for the graphs.
All right. And your next question is, what is the coefficient of variation?
Okay, so this is just kind of a definition question because we use this a lot in Excel and a lot of our slides. Often it's expressed as a percentage, but the coefficient of variation is the ratio of standard deviation to the mean. So it's kind of a comparison between the standard deviation to the mean. There we go.
Wow, excellent job, Hibbs. Super.
McCree, I think you have this one. Just
What
asking.
number?
It's slide
The
16.
question's right at the bottom there.
What changes could be made to make the graphs more similar?
Well, if I change the two of the lowest people, or if I change the height with the lowest person to the height of the highest person and switch them around, then the plot and whisker becomes more similar, because the smaller number for the Army recruiters makes the average smaller, and the height for, and changing the biggest number to the height of the random wall walkers makes their average higher. So it kind of averages out both graphs. What is the difference in having high blood pressure and being obese versus just obese or have high blood pressure from question 3's Venn diagram?
Well, around 3.1% of Americans are just obese, and the 7.2% just have high blood pressure. And you can see right between the middle is 16.1%, and have high blood pressure and are also obese. And it turns out that around 5.8% is the difference between having both obesity and high blood pressure versus just being obese or having high blood pressure.
Thanks, McCree.
McCree, ask Lydia.
Okay. What are these numbers in your Venn diagram, and why are they in millions?
Well, mine weren't in millions. In a room of 26 people, which is in our class, and counting Miss Benzi and her assistant, one of them likely has only type 2 diabetes. If we go by the bisect or the intercept, no, that is
That's right. The intersection. You're right.
The intersection, it's only 0.2% have actually diabetes and high blood pressure. But if you look over at obese and type 2 diabetes, 4 people in that room most likely have some form of it. In obese and high blood pressure, 4 people in that room. It's very interesting because at the age of 20 to 25 to 30, this isn't showing up yet. And in that room, odds are at least one person is joining me in the middle as having the causes and effects of all 3.
Well, Lydia, how profound. I love the way you put this right down to our own classroom. You rock. Thank you. How can a bill charts help to predict the outcome of sleep patterns?
All right, this is to me, if you look at the chart there, you'll see a bell-shaped curve in there. And the way that happens is you'll find the median of all these people. I think the mean is 6.7. In other words, most people get 6.7 hours of sleep a night. And you go from the right and to the left of that. When you're going to the right, those little symbols there mean you add the standard deviation of 2.03 hours to the mean, and you get that on the first one would be 8.73. Then the next one you double that. Then the next one you double that on that one, all the way up to the fourth one on the positive side, and you do basically the same thing on the left hand side, only you're taking away from it on that, and that's how you get those how the bell curve shapes. My son and I played with this, and we changed the mean and we changed the standard deviation. We could make the bell curve very peaky, and we could make it almost flat by just changing the numbers up here we had in the different numbers of hours of sleeping that the people had. And what I learned about the Z-score, you'll see that line in there. That line is kind of my own sleep. I only usually get about 6 hours, 5.5, 6 hours of sleep a night. And so my Z-score is just a little less, not quite 1. It's probably about a half less than the mean is on this particular chart.
So you're saying your Z-score would be about -0.5?
-0.5, maybe, if that much.
Very good. Thank
And
you.
how did the data explain the startup loss and finally the profits of Musk flamethrower business?
Okay, if you look at the graph that I've made here, the green to me symbolizes where he started in business, and I think the information showed that he started out with about $12,000 making these flamethrowers, and he limited it to 20,000. He told people not even to buy the things because he said that, but the people were buying them just like they're going crazy. If you look at the bottom of the chart, that's where he kind of bottomed out. I think he had spent about $120,000, and he had only sold 100 or so fire extinguishers, and so he was about 75,000 in the hole. Well, by the time he got to flamethrower number 203, I believe it was, he had broke even. And then by the time he went to 258 flamethrowers, he had made over $90,000, and he eventually went on to make over $5 million out of a flamethrower business. It was just kind of a fluke that he did. And what was kind of interesting about this to me, and what I used later on in my time management thing, is how Mr. Musk talks about time management. He says that you want to be less wrong. You're going to just figure you're already going to be wrong, but you want to be less wrong than the average person. And so he's busy all the time. He doesn't waste a minute of his days or anything like that with all the different endeavors he has going on. And whenever I had my businesses, you didn't ever have a chance to sit and rest. So I kind of understood where he was coming from.
Excellent. Thank you, Tinny. That was great.
When reviewing Elon Musk's flamethrower business, explain his investment process, his bottom dollar, and his break-even point.
Well, Tinny, you said it best first.
Sorry.
But it kind of like what you said, his break-even point is where he had recouped the money that he lost, but he hadn't profited anything yet. And then his investment process, as you can see with the graph, he had to start with a certain amount and then kind of lose money before going into a profit. And he actually didn't start to make a profit until he sold 203 flamethrowers.
Excellent. Thank you, Bailey.
This one goes to Lydia. How much time do you intend to work?
Well, as you can see from this stacked bar chart,
Which is beautiful, by the way.
thank you. It takes a lot of work to get your business off and going, and I have no idea what I was supposed to say.
Well, this is a very interesting time chart. I've never seen one quite like it. We're milking cows, preaching hope, and designing motorcycles. This is pretty amazing. You definitely don't need to say a lot because you've shown us quite well. Good job, Lydia.
Thank you.
Okay. And what is your perfect diet?
Well, I have always gotten sick on pretty much everything I eat because of my allergies. So my perfect diet, it has the one that always made sense and worked for me was get rid of the bread. It's down at 0%, and about 71% of what I figured I would need is protein, and then 24% is dairy. Vegetables and fruit coming in a little bit below that. If you get too much, you pay for that. I've done it one too many times. So, yeah, that's not something you want to tell everybody.
Well, it's good to share. We can all learn from each other. Thank you, Lydia.
And Janet, how does time management differ from weekdays to weekends?
Well, my time management on the weekend does not involve working, so I took that out completely. But I do spend a lot more time with my friends and family. So if you see my stack chart here, you can see that in orange is my weekend hours and in blue is my weekday hours. And I like to sleep a lot more and eat a lot more on the weekends than during the week. So that's definitely where the difference is. As you can see, there's no working on the weekends unless I have to, and in an ideal situation, there is no have to. So, yeah, right. So I tend to get about 8% more sleep on the weekends, and I spend about 10% more time with my friends and family.
You gotta play hard and sharpen your saw if you're gonna work hard.
That's right. And Lydia, what are the expenses of a mobile mechanic?
Give me 1 second. When you can't see your notes, it gets interesting. Come here, you rascal.
Well, it looks like you have a nice list going right on the screen. Can you tell us about your list on the screen?
That's what the problem has been. I've been trying to do it without. Yes, the normal electric, water, and sewer are really skewed compared to a person living in a house when you're living in a trailer and have to arrange everything differently. Basically, the irony is the sewer price gets up thing, and your power price, if you look, is the very little line down at 0%. It's a tiny little orange line in there. And because, well, solar power just takes annual maintenance and nothing else. The biggest expense then would be reinvestment, because if you're running a mobile mechanics business, you're reinvesting or else.
And that concludes our QL Spring 2019 group performance.
Very nice. You guys did an excellent job. Thank you.
Yeah.
Very, very, very good.
What a chore.